So this is my Sudoku solver project. I'm going to start by demonstrating it. So here it is. This is how it loads. I'm going to load in just an easy problem just to show you how it works. Pretty much what it does is you can step through it and then it makes changes as it goes. Same with the medium. Just step, 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 step. Since this is a little bit longer, I can just hit run and then it iterates through each of the different steps being made. And this number right down here is how many different, like the millisecond delay between it. Here it is, and then it pops up. Puzzle was solved. And if I do a hard, since hard even takes longer, I'm going to reduce this to about 250, and then I can run it. And now it's updating every quarter second. As you can see, there's a bunch of changes. This is the next method it's going to use, and as you can see, it solves it just like that. A walkthrough of my main file. We are using windows.h and iostream in this, as well as a few others like chrono and thread, and this is for different delays. As you can see, the void delay is using chrono and thread, and that's just to stop it from running for the run function, as well as Windows was pretty difficult to use. Most of this was initialized to begin with. However, a little bit see down here, there's different buttons. I was able to learn how to figure out how to make the different boxes, as well as this callback. This is where everything works. So if I press the load button, the step button, as well as the run button, does different things. And we'll walk into what that does in a minute. The hard part about this, I believe, is down here. This is how we, draw the grid, which is this size, which wasn't too hard. Able to figure that out and then just kept it. The difficult part, and I have to say I did have to use chat to do this part, was just figuring out what spacing I needed for the text font to make it small, to make it big. It was a big help in that. And then the board loading was fun to figure out, the different places for all the pencil marks, as well as the text at the bottom that changed dynamically. Node is the smallest, it's just a single cell. The way that node works is node is going to have a number, a viable, an eliminated, and critical squares. The thing that I think I learned most about this is vectors. They do locate stuff dynamically. However, for this, I wanted a node pointer instead of just a node, because otherwise I would be duplicating nodes and it would pretty much be recursion. There's different methods for this, such as add crit, get population. And these just iterate through and check to make sure that you can eliminate or you can update, and then you take away an elimination, stuff like that. Group is similar. The group obviously is a group of nodes. We have an is box, so it's true if it's a box, and then is row is also true if it's a row, and then if both these are false, we can know that it's a column. Something that I learned here was the pair. Pair is super important. It can return two values. Obviously, I'm returning 4 in this because I have a vector, I guess more than 4. I've got an array of 4 values coming back, and this is the forward function. It will remove those pointing pairs from the row or column that it associates with. But that's the purpose of pointing pairs. The board is pretty straightforward. It initializes it. It has 81 nodes in an array. It also has 3 group arrays, 9 each, rows, columns, and boxes. It was fun to just figure out the math to iterate through the boxes and all the columns and rows inside the boxes. And then there's a step, and this is what is used to either do one step, and then we just call this multiple times the delay in the main loop to run the program as if it was calculating everything else. And then each one of these, find hidden singles, or it will check crit, which is just the naked singles, and then it returns what happened back. So that is my program. Um, the big thing that I learned from this was vectors